So hello, thank you for introducing me. Let's talk about effortless software development. The reason for this talk is because some companies are actually up to 300 years behind on their backlog. You may think like, wow, where did that number come from? We actually checked a backlog for a company where we worked once, and we extrapolated based on how long it took to, on average, to create every feature. And so it was estimated that all of that together will take roughly 300 years. So it's just impossible to accomplish. So I want to share some advice that will help you remedy that. And we're going to talk about not just the code, the methodology in general. So I'll show you some of the things I actually used in projects and how it helped really trim a lot of the fat from the processes. So it's not just about the code, it's also about these other tasks. So the first thing you need to do is figure out all the requirements. Okay, so you spend some time, you sit together with a team, and then you produce a 50-page document, okay, which will probably offer very little context about the business motivations. You might actually go and amend an existing 50-page document. So I was an analyst on many of the projects, so I was the one who had to go and edit those documents. So yeah, because there's very little context about what made us create this feature, those documents are often, I would say, pretty useless. And then, of course, you have to go and approve those documents because you have to follow the process. And this is a very enterprise process. I worked on several such projects in the last few years. So you have to approve that. And then once you approve the document, great, you can start writing the code. So this is the part that we like, writing the code. But then that's not over, because while you're writing the code, you have a question or you need access to some database. So you email and you wait on someone else to provide you, to unblock you so that you can continue writing the code. And once you got through all those hurdles, you have merge conflicts, because obviously you had this feature branch that was open for like a month by this time, and because you were always waiting on someone else to provide you some more information, and those merge conflicts took a week just for that. So yeah, you have to finish all that, and once you're done, you are still waiting for user tests, because then you have to wait for someone to tell you, is everything that you shipped okay? And then you're done. Or are you? Well, they come back and they say, hey, you are missing some requirements. And you go back and say, what requirements? Like, we didn't discuss this at all during the first stage, because people did not communicate that information very clearly to you. So some things were very obvious in their head and were miscommunicated. So now you have to go and maybe even redesign everything. And then someone that you never heard of disagrees with the requirements. You receive an email and somebody says, well, after all of those user tests are done, they say, well, this thing does not work the way the department needs it. So could you kindly change that? And that, yeah, changes your whole design. You redesign, and then you have to basically start everything from scratch. And you can continue with that for a very long time. But that's not all, because while you're writing the code, you still need to figure out a bunch of stuff. Like in the code itself, you have to figure out 20 levels of inheritance, you know, this extends that and so forth. And then you have 800-line methods to sift through, sometimes more, and understand what the hell's going on there. And in there you have 6 levels of nested ifs, so you have like very code with a lot of indentations that you just can't wrap your head around. And then you don't know how to unit test any of that, because it's maybe not even testable. Maybe it requires you to bootstrap the entire framework before you can write a single test. And that doesn't make it a unit test anymore. You have to figure out whether a variable that you're looking at is null right now, because maybe it was supposed to be set somewhere else and wasn't, because all of this is very fragile. And things have to be called in a very specific order for that variable to not be null. So by the time you reach a location where you need to use that variable, it might not have been set yet. And then you have, in all of that 800-line method, you have, you're using array 2. but you don't know what it contains. The name is meaningless, and you have to go back and maybe even to other methods to try and understand what the hell is in there, and is it even an array at this point, because you know how PHP is. And then all you have is just despair, because nothing ever gets done. You have this huge process, you have this terrible code. So how do we get to the good parts faster, and how we can trim the fat from this gigantic process? How can we put less effort into the process in order to get a better result? So I know I've been introduced. I'll just recap this. I've been coding since '97, PHP since 2003. I like to dig into old code bases so you don't have to. I am very fond of test automation. I give lots of talks and workshops. And you can find some YouTube videos that I created to help you understand certain programming concepts. So now let's look at how can we make this big process simpler? Well, there are three parts to it. The first one is to write better specifications. I mean, right, we all know that we need better specifications, but what do we often do? We just blame the bad specs on someone else. Well, they didn't tell us this, they didn't tell us that. But sometimes when you're on the other end of that situation, you realize that you have communicated things to the best of your abilities, and yet the other people did not quite understand what you meant. So you need to find a common language, something that provides mutual understanding and agreements on what needs to be done. So the way this usually works, and I'm talking a lot about enterprise approach to things, you discuss requirements with a whole bunch of people. Everybody has an opinion, and then you emerge from that meeting with a 50-page document, which obviously will not contain all the context because there's just too much information, but you go too much into the details. It will also become very quickly outdated, because if you put it on Confluence or SharePoint or Google Drive, that document will just rot in there and will become out of sync with the code that you're going to write, because you're going to make changes. But nonetheless, companies do that. They just put those 50-page documents up, and then you start the development. Great. But then you have a question during the development, and it takes a long time to get an answer because people are going to discuss that between themselves. It just takes ages because it involves often email chains with dozens of people who each have their own opinion, and you might not even get an answer before the end of the sprint, so it's going to have to be pushed to the next one. But if you're lucky enough, you get an answer just in time to finish development. And once everything is done, someone will go and test it. So user testing, or what people call end-to-end testing, somebody's going to manually go through everything that you wrote and go all the way to making sure that the credit card transactions show up, in the Stripe or whatever, or whether the emails have been received correctly in their inbox, or whether the attachment, the calendar attachment on the email went to the Outlook calendar correctly. So those kinds of tests. And then they're going to come up with a list of use cases that we missed. Right? Because they weren't communicated. But sometimes it can get you all the way back to square one. And what happens at this point is you have to go and add those missing use cases, often leading to a redesign because those use cases are significant enough to change your understanding of what needed to be done. And then you have more questions and you wait on that. And then there's more testing, and this can go on for months. So simply because you use Agile and you have sprints is not helping solve this problem at all. You just keep adding the same user story to the next sprint with new tasks, and it just can continue forever. In one project, I had a code review process because somebody else reviewed our code. That took 6 weeks. The code was working, the code was satisfying all the requirements. It took 6 weeks just to get that reviewed. And the sprint was 4 weeks. So it took more than a sprint just to get that reviewed, only to get back with a list of requirements such as, oh, can we please add 2 spaces in between of methods? It was crazy. So the solution to that is, first, you want to have a product owner. You don't want to talk to a committee. You don't want to send an email and then there's like a dozen people in CC and then everybody just bickers, about what this should do. let the product owner handle that side of things. If they have a committee, the product owner is going to talk to them, and they're going to distill those requirements down to something that they can communicate to you with confidence. So their whole job basically consists of talking to all of these people and understand what the system needs to do. It also ensures that there are no two requirements that contradict each other, which can happen when two people have a different understanding. And after, you also have to have direct and quick access to the product owner. And they usually, should not have any other roles in the organization. They should not also oversee whole departments. You need to make sure that these people, their job is to be a product owner. They talk to those people, so you as a developer don't have to talk to an entire committee and then have contradictions in what you get. The product owner also should not delegate questions to that committee. So if they cannot answer the question, they have to go to these other people and then distill that to an answer that you can trust. And then the great thing you can do with that, because you only talk to one person, you can very easily communicate requirements using acceptance tests. I mean, even if they then validate that with their committee, it doesn't matter. You can discuss those acceptance tests with them, and they have this global understanding of what everything should happen, all the things that should happen, and you can communicate that in a language that they can understand, but that's also something that you can use, because without these tests, everything is still vague and subject to interpretation. So here's an example of such tests. I usually use Gherkin, which is a format for writing specifications, and it's something that is supposed to be human readable. You can always write them in a non-human readable way, but the whole idea is to have simple sentences that people can understand, that don't go into any technical details. So a scenario is, let's say you offer some product, you offer some service software as a service, and then users can subscribe to various plans with a credit card. So how does a user subscribe? Given that, so I as the user, given I selected a membership option, when I enter valid credit card details, then I should see a payment receipt. Now, these tests can be written at first and discussed with the product owner. And then once you agree on these, you can convert that to BHAT or codeception. So basically you can associate code to execute with each sentence, and you can actually have an assertion at the end, making sure that you can actually see a payment receipt. And the good thing about this language is that it is centered around the user. It does not focus on technical stuff. And you can be very confident that what you provide is something that the user expected. So for example, how do we know that the transaction succeeded? Well, at least the payment succeeded. We don't go fetch into a database. We don't care. Like when I shop on Amazon, for example, I don't care that something has been inserted into the database. I want to see a payment receipt, because I want to be able to take that payment receipt and show it to them. If they don't ship me the product after a week, I'm like, hey, where's my product? Well, you never bought it. Well, here, I have a receipt. Could you kindly send me the product now? And they're like, okay, cool. So I need the receipt. And that is what constitutes a successful transaction, as something that is very actionable. So you can verify that a receipt can be displayed, and that sort of encompasses the entire scenario from start to finish. And what you see here is a happy path, what I call. So basically, this is the most basic scenario where everything is good, because you see I entered valid credit card details. What happens if I enter invalid credit card details? Well, that's another scenario. But I like to have these even inside of my user stories. So during the grooming process, I would write the happy path, and that makes the user story ready to sprint. Because not only do we understand what it does, but we also know how we're going to test that. Because the hard part, I would say, is not even writing the code, is how do we ensure that it works the way it's supposed to? You don't have to focus on user interaction. So you can write something more specific, like applying a single business rule. So for example, and these are all scenarios that I wrote in actual application, just different data in there. But these are things that I wrote for a discount system. The discount system would check things like, is it a particular date? Is it a particular product? Are you, as a user, are you of a particular membership level? Things like that. So you would get discounts based on a variety of criteria. So what we can do as a test here is say, well, given we have a 5% discount and we give it a name, it can be an arbitrary name, it can be XYZ if we want, but 5 just makes it easier for us to read the scenario. Given the discount 5 active on, between throughout the month of January of 2019, and given another discount of 10% active, in February, and the current date is January 15th, when I check for discounts, then the 5 discounts should be found or applied or whatever you need to do with it. So this is not from the perspective of a user directly, but it does allow you to check for a variety of business rules. It is something that is extremely useful in environments where these rules can be audited, like in a bank. So in a bank, you can process CSV files, and then you have to apply a whole bunch of rules there. And there are legal requirements, basically, what you can and cannot do with those rules. So banks get audited for that. And because of this, it's very nice to have those tests to prove that you have satisfied all of these requirements. So basically, your requirements at the end of these discussions, with the product owner, will be a collection of use cases that need to be accounted for. So once you have all of these scenarios, you can start the work. Make sure you use natural language, no programming talk, no mentions of databases as much as possible. Like, don't go into the technical details. So let's see what happens when we switch the previous process of gathering requirements to using use cases. So we gather requirements, and at the end of this meeting, we emerge with written use cases. So those Gherkin scenarios. And they don't have to be written as Gherkin scenarios. Some people, they might find it too programming-like, so they might be intimidated. Business people, they really like boxes. So this is the exact same scenario, like the first scenario that I rewrote as a sort of a diagram with arrows. It's very easy for everyone to understand. And before you know it, even the companies who are initially impossible to convince to switch to Gherkin, they will eventually provide you themselves those diagrams. So they will come into the meeting to discuss requirements, and they will already have all those boxes. And you just make sure you understand what all of these, you change the language a bit and stick them into your Gherkin scenarios, and you can start work. So this is a nice way to transition the big enterprises into something that's more convenient for us. So after that, you can start development. And if you have questions, what you get back is not just an email with an answer. You will actually try to nail down a new scenario. So you can have an edge case that you discuss. And that's actually really cool because you can postpone certain decisions. I had a situation where I had a client where we had a PO, but the PO could be overridden apparently by other people. So they could chime in and say, I disagree with that during the meeting where we're supposed to receive the requirements. So they had most of the requirements nailed down, except for one edge case. And we nailed the requirements in 30 minutes and then spent the next hour bickering about this edge case. So I told them, hey, how about we start development? And while we're developing this, which is going to take a few weeks, while we're developing this, you can then discuss what you want to do with it and tell us. We'll make sure to account for that in the design so that we can easily decide what to do, based on this or that scenario. And that postponement was very helpful. It allowed us to start the development weeks earlier than if we had waited for people to discuss the scenario, because they had to check with a whole bunch of other people. So it also reduces the number of issues that come up during user testing, because then you accounted for all the scenarios. And in a real project where I used this approach, a different project, I had user testing where the only problem that they found was that when they received the email in their inbox, the new lines weren't done properly. And that was because we were told that the system was sending emails in plain text, but apparently it was sending them in HTML. So new lines needed breaks. And that was the only issue. So just one little unknown that took 5 minutes to fix. It was beautiful because in the past, they would come back with tons of issues, and they would spend the next 2 sprints just slaying all of those issues. But now no more issues because all of them are eliminated through the execution of those scenarios. So once we have those requirements, the second thing that we can change is the design. So the design is basically, what are your classes, how they interact, what are the different components in your code. If you do everything up front, it's going to be really hard to adjust when you inevitably make a mistake, because you cannot account for everything until you get your hands into the code. Let's say you're dealing with legacy code. You assume that things work a certain way, or you have a fairly good understanding. But once you get really deep down into the code, some of your assumptions are shattered, and that can have an impact on your design. Or you can realize that some parts are not even necessary because apparently you had a microservice that gave you exactly the information you needed, and you just need to communicate with that, and you can finish, your feature in a day. So be careful here. I'm not talking that we should not spend time on design. It's just we shouldn't do all of it up front before we write a single line of code. So let me show you an example. This is what happens when you do all of your design up front. You can spend weeks designing, and then you have to get it approved by all the technical people. So in some large companies, they hire a lot of juniors, and therefore they have these people who are there to approve your design before you spend too much time coding. And that's fine. That's great because it allows juniors to contribute very easily and learn from the inputs, during the approval. The problem is that they design everything up front, and people will come back and say, yeah, this design looks good based on what I understand your problem is. And then you start coding and you realize that design is no good. So once you start coding, you find cracks in the design, which is especially true in legacy code. And so this assumes that basically you know everything in advance and you're not making any mistakes. So now you during the design phase, you spend even more time because you're so scared of making a mistake and breaking this process. You should change your process instead. You shouldn't have an environment or a process where making a mistake is so critical. You should be able to catch those mistakes. Now, so there's a nice quote by a Polish-American scholar. The map is not the territory, and you may have heard that. Basically, you have a map, you think this is what you'll get, and once you are there on the terrain, you see that it might be completely different, which is why planning everything up front is a problem. So if you don't account for a detail, is everything going to be broken? Well, no. Instead, what we want is to have an approach where we are able to adjust. So have a process and have a design where we can easily switch gears and basically have a situation where we can design a little bit, code a little bit, inform our next steps, design a little bit, code a little bit, and just continue this way iteratively. That's why I call it iterative design. So the approach to that, the one I use sequence or activity diagrams. So the sequence diagram is usually when you have a single use case. I actually use that for all of my features to at least demonstrate the happy path, because it's something that's very easy to communicate to the front-end engineers, because I usually work on the back end. I can show it to the front-end engineers, I can show it to the PO, and it kind of makes sense. It's very easy to read. You can also use activity diagrams if you want to encompass multiple use cases. So if you have conditions like based on whether the credit card is expired or the postal code is bad, you can have different outcomes, and you can show that in an activity diagram. And so then you are going to write minimal code to validate the design. So those two things I will show in depth in the next slides. It's an approach that allows for information to flow more freely between the code and design, and it flows both ways. So your design can inform what code you should write, and the code might inform what design you should do, how you should redesign based on what you're dealing with. And it prevents us from spending excessive time on details that may prove wrong anyway. And a lot of them do prove wrong. It's very hard not to make any assumptions, no matter how good you are. And I've been doing this for more than 20 years. I like to split. So this is a sequence diagram. I like to split by application boundaries. So if I have like a third party, like a payment gateway, I would represent that as another lane. And so at this point, let's take the first Gherkin scenario that we wrote when the person selects a membership, pays with a credit card, and sees a receipt. What does that look like on a sequence diagram? I try to make it symmetrical so that the language just continues to be similar to what we had in other areas, and that just makes it very easy to translate and fix the other thing if we find issues while designing this one. So the user is going to select the membership with the UI, because we have two different applications. We have the front end and back end, for example. And then the UI is going to create an order by supplying a product code. And the API is going to return an order object that we can then present using a payment screen. So it's going to say, the taxes and everything. And then the user will enter the payment details, so the credit card. And using that, the UI can tell the API to finalize the order using the credit card information. And from there, once it processes the payment, I sort of obfuscate the implementation details of which payment gateway we're going to use in this diagram, because in that case, it doesn't matter. If it did matter, we would somehow highlight it in the use cases, and then we could have that additional lane, because we might want to have different payments providers, which I had in one project where people were allowed to pay using Visa checkouts, Apple Pay, and just plain old credit cards, their loyalty points from the company. So then you get a receipt, and then back to the user. And with this, we are ready to write code. So now, once we start with the codes, the problem that a lot of people say, well, there are too many cooks in the kitchen. So in the end, everybody wants to work on their own user story, because they want to basically split the work by saying, well, I don't want us stepping on each other's toes, therefore I work in my bubble and you work in your bubble, and we don't really communicate. So you start all of the user stories at once, you don't finish a single one because there's too much for one sprint, for one person. And so, and you cannot split it into smaller features. So you are stuck basically not really shipping anything, and it demotivates people very quickly. Morale drops, and people are even less productive, and you ship even less code, and it just snowballs from there. And the justification for that, why people don't want to work in the same features, is they say, well, we don't want to work in the same classes, we don't want to duplicate efforts, we don't want merge conflicts. But you can avoid that. So instead of avoiding avoiding working on the same user story, what you can do is avoid the process that causes those problems, because the root cause is not the fact that you're working on the same feature. The root cause is something else. And I'm going to show you how you can design things in a way that allows you to work in parallel on the same feature and ship things a lot faster this way. So the solution is to first start with mob programming. So basically you get everybody in the same room, or Zoom chat, Zoom conference, because we cannot be in the same room at this point. And I shall actually use that also for when offices were split across multiple cities. So we had half of the team in Montreal, half of the team somewhere else in Quebec. So we would sit together and validate the design. We will basically write the minimal code necessary that will highlight, outline our. And after that, we can split the work. So I'll show you the exact process for doing that. You can split then the work by working on the implementation and the tests. So one of the devs is going to share the screen and then is going to start typing. and the other people can comment and can ask questions, and we can look at diagrams. And we start with this diagram that we initially wrote. And since we're working only on the API side, there is another team working on the UI. We just need to satisfy the requirements of the UI. So how will the UI communicate with us? So they're going to send us a product code. They're going to ask us to create an order, and we're going to send them back an order. So that's basically what all there is to that first part. And so you're going to have to create a controller for that, or also called request handler. So one way to do that is create a class specifically for handling that particular request. So all it's going to do is it's going to receive a request object, and it's going to send a response. So that kind of makes it, again, very symmetrical to what you've seen in the diagram. And once you have that, you can instantiate a product code by supplying it the string value that you got from the request attributes. And the reason for that, I'm going to get into some more details about value objects later on, but value objects really allow you to have, to wrap a value in something that allows the value to be, to prevent the value from being null or false or empty, because you don't really know the type of get attributes. Or maybe you want to make sure that it does not exceed 15 characters. You don't even have to decide all of that up front. All you need to know is you want to have some sort of logic around it. It's going to help you. I'll show you some details in a second. So all we know, once we have the product code object that we can work with, all we need to know is, well, we need to get the product, because we want to create an order, and maybe we don't want to create the order directly from the product code. Maybe we want to get the product with all its information. The information might contain, all the price, the pricing for that, the name, other things that we cannot obtain from the request itself. So we're going to find it in product storage. The way it's stored, it doesn't really matter. Is it are the products a database? CSV file, microservice. It's not really our concern at this point. What we're trying to do is put all the pieces together that are necessary to receive the request response, and then we can focus on those details later, because we don't want to code everything together. It's going to be a very long meeting if we do that. And then from the product, we can create an order. Again, we don't know how the orders are stored. We don't care. And with that order, we can then return a JSON response. So the order has been created. We now have the information about the taxes, whatever you want, and we return that. The exact details, again, of what's going to be returned can be decided a bit later. You don't have to decide everything up front. You just need to see how all of those pieces will interact, what kind of parts of the application will you need to interact with in order to satisfy this request. And the thing is, it's worth spelling out the entire handler while you're sitting with all of your team, because it allows you to ask all the right questions. It's the glue that holds everything together, so it will inform what kind of classes you will need to create. It should be as simple as possible. You see, this is very simple. It's like, 17 lines of code. And it will guide you for the rest. Now, here, note the dependencies. We have products and we have orders. I haven't defined those anywhere, so we're just going to inject them. So this is dependency injection. If you're not familiar, you just supply them through the constructor, and they become available to your class, and then you can call the methods. And you don't have to implement them right away. So product storage in this case is an interface, and order storage is an interface as well. And because they're interfaces, you can just, once you define that, you can stop right there. And you can go ahead and start unit testing that controller without worrying, because it does not extend from the framework's abstract controller. It has no other dependencies than these interfaces. And so in your test, when you want to instantiate this class, you just provide mocks for the products and the orders. And the mock will be like in PHP unit, it will be this create mock product storage : class. So you don't need an implementation because you're going to mock everything. And so again, with the entire team, you need to define those interfaces. You need to at least know what methods they will contain. And that information you will get from the controller that you wrote, from the handler. So in the handler, remember, we call get by code, and we supply the product code, and we received a product back. So you just need to define that. And whoever is going to make an implementation for the product storage is going to worry about how to satisfy those requirements. And then same thing for the order storage. We will receive a product, and we will output an order. So at this point, you're pretty much done. So you only add the methods that are used by our handler. You are not going to add methods that you think you might need, because then you will need to implement them. And because they're not used, it's going to be dead code. So you're going to design with dead code in mind. So if you don't need them, don't create them. Here, you can notice that we'll need those extra classes. So we created the interfaces, but we still rely on the product code, the product, and the order. So these are value objects. It is the data that will circulate between our classes. Those VOs are pre-validated and immutable. I will show you in a second what that means. It basically controls the continued validity of the data. And it's one of the keys to avoid messy code. And you can read up on value objects if you want. I even have a video that shows in depth how these work and how they're useful. So once you create all of these classes, it's really easy to implement the interfaces. And so let's just implement one of those. Let me just show you what one of those value objects might look like. So the product code, it's very simple. It's final because you don't want to be able to extend it and override the constructor. The code is private because you don't want to be able to set it from the outside. This will ensure the continued validity, so you don't pass an object around where it can be sent to null, and then all of that has been for nothing. In the constructor, you receive a string. It's not enough to know that it's a string. It might have additional constraints, such as being not blanked and also not exceed 15 characters. You don't have to write that validation. So assert is a library basically that will throw an exception if any of these criteria are not satisfied. And that will allow you to write code that basically, if it runs, it works, you know. So you don't have to write the assertion parts up front because you might not have that information when you're initially designing. You can uncover that information during the sprint. Otherwise, you're doing too much upfront, and you're blocked because now you have to go and fetch all that information, maybe sift through hundreds of pages of documentation somewhere on SharePoint. So you want to avoid that. And then you just have a getter, and that's it. So later you can refine this object and you can add tests to it. But for now, just write the strict minimum in order to be able to basically unit test everything. And so that's it for more programming. What you wrote at the end of it is 13 lines of handler, 8 lines worth of interfaces, 46 lines worth of value objects, probably fewer if you didn't add any of the assertions there. And in the end, what you get are 67 lines of code. And I mean, this is very little, and it covers half of your feature. So you have designed half of your feature in under an hour with 67 lines of code. What do you do with this code at the end of that meeting? You open a PR, merge it into master. Because it's not wired into anything at all in your application, it's actually safe to commit. It's just that it's not doing anything. And then if you do need to extend, it's well if you have sort of a greenfield feature, but if you need to extend existing behavior, it might be a bit more tricky. So you can use something called feature flags. You can read up on that too online. Basically, you make some paths disabled until the entire feature is shipped, and then you can toggle it on and just remove those flags completely, and you can then make one final merge to master, and your feature is ready. So it allows you to have a shared vision also amongst all developers, and everybody can have an input, and the juniors in your team can learn. You know, if the more senior people are good at design, they have a good understanding of how to design good code. the juniors can learn from that as well. They can understand the process, the thinking process behind that. So it's a great learning tool as well to sort of increase the skill level of other people on your team. And once this is done, you just have to decide who does what. You split the work. One person can test the handler. Another person can implement one of the interfaces. So they will create like let's say a database product storage, or a CSV product storage, or like a microservice, product storage. So they will create an implementation, and they will write the unit test for that, or integration tests if they have to check communication with the database. And because you have two interfaces, basically you can have two devs working on that. They're not stepping on each other's toes. The interfaces are well defined. They don't need anything from anyone else. They're not working in the same classes at all. So now you already have three people who can work in the same feature without stepping on anyone else's toes. But then you also need to implement the validation of the value object and write tests for that to make sure that this validation works. So that means we had, what, 3? So that's like a whole bunch of people. You can have like almost 2 teams working on that one feature without stepping on each other's toes. So you just allowed to have a lot more cooks in the kitchen. And this is not over, because somebody has to implement the different steps of the acceptance test, right? So, given this and, when that's, then all of these steps need to be implemented in BHAT or Codeception. Somebody has to do that. So that's another dev. So now you ramped up to a very big team that can work simultaneously. So we also know that everything will integrate together perfectly, because we already defined, all the glue that holds it together. We have the interfaces, so there is no risk of, you create something and it doesn't fit with another piece. Like, we created the fitting first, and then everybody makes their own implementation. If you need to make changes to the design, you can, and I'll show you an example. So let's say we have this order storage, but we now need a country, right? Because the country is maybe can influence, which products are available where. I know that iTunes wouldn't allow certain songs in certain countries, things like that, or certain books are not available. So you might want to add this additional thing. And that means that everybody else's work is going to be impacted by that. Well, not everybody else's, but the person who is implementing, who's writing the concrete implementation for the order storage. Well, if you need to add the new arguments, get back with the team, discuss it, send a patch to the master branch, merge it there. Everybody can then rebase and continue working as though nothing happened. So the changes to the design are actually very cheap, unless you have to scrap everything and start over, which will probably not happen because you've written so very little. So unless the feature completely changed, or they decide that this is no longer the feature, at that point the story is invalidated. So small iterations, and you add things as you uncover new information, and you don't really impact anyone else's work. The person who has been working on the order storage merely needs to update a couple of tests, and that's it. So for the acceptance tests, there are several approaches. It depends on what parts of the application you control. If you control both the backend and front end, if they're like the same application, then you have to have some sort of, Selenium test, or Cypress is now pretty good at testing these things. So you can have something for both the backend and front end, but you can also have just the backend. So if you're only working on the API side of things, these are pretty simple tests to write. We'll basically just send HTTP requests to the API for every step. So this is an example of the previous scenario that we wrote. What I usually do is, before I commit that to the code base to master, I don't want this to break my CI, because these steps will fail, because obviously none of this has been implemented yet. So I just have a tag which I exclude from my CI. So when I run my suite, my BHAT suite, all the work in progress tags are excluded, which means that I can remove it just to run the test and then put it back there, and not have to commit it until it's ready. And then I'm going to, so these steps are going to call the necessary endpoints. So the first one will call the create order handler, and the second one will be another handler that you will create. And when once each step, the implementation for each step is completed, so the associated endpoint exists and it works, you can run the scenario and validate whether that step works. And when all of your steps pass, then you're pretty much done. You can remove the work in progress tag and commit this final code to master, and remove all your feature flags and whatnot. So that's pretty much all you need. Once all of these scenario pass, you are done with the user story, and then you can that's it. You have satisfied every single use case. You have tests to prove that they are satisfied. They're pretty complete tests because they call the application as a black box, so there's no problems that you forgot, some routing configuration and things like that are not really unit testable. So you can go ahead and cache in those story points because you're done. So let me just recap this real quick, and we'll have some time for questions. I don't know what exact time we need to finish because I know we started a bit late. So the lessons learned is that code is living documentation. You can have documentation for the users in Confluence and things like that, but you can have actual scenarios outlined in your code that are both useful to the product owner, but also to the developers, and they provide this shared understanding. So once you satisfy those scenarios, you have proof that you have accomplished this objective. Also, don't try to figure out everything up front. There are a lot of unknowns. So if there are edge case scenarios that you're not sure of, you can leave them for later, unless you think that it's going to change everything, it's going to invalidate your design. Then maybe you should, put this back into the backlog and groom some more and gather more information. But don't try to avoid mistakes, basically, because mistakes are normal. Basically, fail fast. You create you start creating your controller, your handler. You see that some things are missing. You can fail fast. You can go back to the drawing board, but you're only redesigning 15, 13 lines of code. So you haven't lost much. At worst, you lost 20 minutes of work. So yeah, fail fast and work together more often. So I talked about mob programming. I talked about discussing the scenarios with the PO. Instead of documenting something, spending a lot of time working on your own, making a big document, validating with someone, waiting for them, because they have to find the time to read it, then they need to read it, then they have to prepare feedback for you, and then you have all this back and forth that just never ends. You can work together more often. And so further topics, I would like you to, after this presentation, when you have time, go read up on additional topics. I have actually covered all of these topics, like domain-driven design. When I talked about value objects, that's part of domain-driven design. You can find nice books on that. Test-driven development. So make sure you write your tests before you start writing code, or at least test everything that you write. Make sure that your code passes all the tests. If it doesn't have a test, it's like the code doesn't exist. So you need to have full coverage there. Behavior-driven development, short BDD. That's when I discussed things like BHAT, with Gherkin. You start from the behavior, and then your design is informed by the behavior that you're trying to satisfy. I talked about solid principles, dependency injections, using interfaces. Those are solid principles, so you can read up on that. I actually started a YouTube series on the subject. Only got to the first one. I still need to make 4 more videos. I need to find the time. It's been crazy times. Very hard to find time. Kids are at home, so they don't go to school. You can read up about clean code. You can read up about extreme programming. So mob programming, all these things, extreme programming, you can read on that. Scrum, so when I talked about iterations, when ready to sprint and all these things, having a product owner, Scrum, or at least read about Agile, but Scrum is a pretty good approach. So all of these things together allow me to write software effortlessly. And thank you very much. I will put these slides on Twitter after the talk, and I'm ready to take questions. Please let me know what time I need to finish.
Awesome. Thank you so much, Anna. That's so brilliant to get everybody together and just get that mob programming working and like the boilerplate, and everybody sees the pieces that they can work on. That's to unblock things is brilliant. Thank you so much. We do have a question from Ivan from the Zoom room. So if we, as we're waiting for Ivan, oh, he's already there. That was quicker than I expected. Hello, Ivan.
Hi. Thank a lot, Anna, for your report. I have a question. What do you think about performance? For example, if we have some kind of high load project and we are processing like tens of megabytes of data, and we have to create a lot of classes for every piece of data, it would be a lot of memory. For example, hundreds of megabytes of memory used, and a lot of load for CPU. What do you think about performance in the DDD and your approach? Thank you.
Are you talking about load tests in general, like how to perform load tests, or how to create tests that touch the database but you have a big data set?
No, I mean that exactly in PHP code, we're processing a lot of data. So, for example, we're processing thousands of users, for example, in one request. Okay. So if we create for an object for every user, so we have to fill our memory, for example.
Yeah, I mean, there are ways you can use things that like yield, so that when you iterate, it only creates the object when you need it. So there are, it's much more technical. I don't want to get too much into the details, but there are language constructs now in PHP 7 that can help you with that.
Excellent. We also have a question from Roman.
Hi. I cannot hear.
You hear me now?
Yes, now we can hear. Yes.
Cool. Thanks for the talk. I also enjoy reading your Twitter, and on Twitter you post sometimes really amusing legacy nightmares. And my question is,
so you read my thread.
Sorry, can you hear me?
Yes, there's a delay.
So if you had to give only one advice on dealing with legacy code bases, what would you say?
Just about an hour and a half ago, I gave a talk specifically on that at a different conference. But one piece of advice when dealing with legacy, I would say don't try to tackle too many things at once. Small steps, make sure you have tests, and continue with that. But yeah, if you check my Twitter, there's going to be a video that will be published on that, and I really cover all the different strategies for tackling legacy code. Will be much more appropriate advice there.
Cool, looking forward to that. Thank you.
You're welcome.
Awesome. Thank you so much, Anna. If you would like to join Anna and others in the Q&A room, check out the Zoom link that's been posted in the chat.
Hello, I've been muted for a second there.
I actually have more questions to you. If anyone would like to jump in, so feel free to unmute yourself. I can see a video from Bernard. Bernard, if you want to ask a question, please go ahead. And Okay. Meanwhile, I will ask my question. So,
Go ahead.
so you said one of the solution for this when many people when you get requirements from many people is to have one person product owner who is like source of everything. And my question is, what if he or she is responsible, but he's not doing his job right? And you cannot kind of escalate that. So I, as a developer, what would you recommend in this case for me?
Yeah, it is very hard because I have worked in companies where I had good POs, I had bad POs. I had POs who didn't have the power that I thought they had. So like they would make a decision, they will give me information, and then somebody's going to say, no, this is not at all what we're going to do, but you're not my PO. So it was kind of hard, basically having too many bosses around. So it's very hard, and you need to bring it up with the company. You have to say, well, the PO owns the product and the PO has to be available. If that person is not available, basically try to raise that as a blocker with every, at the meetings where it's appropriate. Like you said, well, I asked the PO a question, I emailed the question, and the PO was, cut in meetings for 2 days and I still don't have an answer. That's a blocker. So just raise that. And if you have the opportunity, like if you, let's say you at some point work with several different teams in a larger company and you find a PO that you like, you can just ask to work with that PO. This is something I did. So I was working at a company and I had a PO that was pretty much absent. And then I was moved to another team where I had a really great PO, like an elderly gentleman who was very, very smart, and just we were able to communicate so well together. So what I did is at some point I said, I went to the director of development that supervised the whole project. It was like 200 people in the project. It was a huge, huge legacy rewrite. And I said, here are the 3 members, the 2 other members I want on my team. Like I want a team of 3 members and I want this PO. Can I get that? And we had dinner together with that guy and like his boss too. And they said, yeah, okay, sure. Because they've seen what I could do. So they gave it to me. But it's not easy to get the appropriate leverage for that, but try several times. Don't be afraid to ask for things. I know that sometimes I have to ask 3 or 4 times for something over the span of a month or 2 months, and eventually I get it, on the last try. So just because you were told no or it's not a good time, don't be afraid to ask. You have to be very assertive. That's how you get things.
Yeah. I mean, sometimes you kind of may feel yourself like too annoyed to ask the same question many times, but maybe it just makes sense.
Well, I mean, you have to gauge. Like some people do get annoyed, but at least I know in North America, most people sort of understand it, that being assertive is not too frowned upon. I mean, I tend to get overly assertive, but it's not too bad here, so it passes well.
Cool, thanks. We have actually a hand from Bernard and Zahar. Bernard, please go ahead, ask your question.
Yeah, and the others who aren't talking, you can mute. I think I'm hearing something from a different microphone. Bernard, are you attempting to speak?
You're very quiet. We cannot hear you well.
Try to speak directly into your computer's microphone, wherever it is.
No, we cannot hear you. Yeah, maybe you could. Do we have a chat here? I'm not sure. Maybe you could write your question.
No, there's no chat option.
Okay.
You can send me a DM via Twitter.
Oh, you can write your question in a YouTube stream chat, and I'll read it.
Oh, okay. We can do that as well.
Yeah.
Okay, go ahead. In the meantime, if somebody has a question.
Yeah, there's also Zahar.
Yeah, hello. Can you hear me?
Yes.
Yeah, okay. So I have some personal pain. We have some arguments with colleagues. So we are working using test-driven development. And when I usually write some new class, yes, for example, it has, I don't know, 2 dependencies. And I say that I think that we should mock both of these dependencies and to list in the mock all the methods with expected return values to
Stubs,
test,
yeah.
yes, like a stub to test that the code works exactly as we want to. And when we are writing test, we're thinking already how will we call the methods, in which order should we call them. Of course, then we refactor and change something, but that's the ideal scheme for me, because you do not only check the return value, because it can be returned right by mistake. Yeah. So what do you think about this approach?
I mean, basically what you're discussing is what they call the London style of testing versus the Chicago style of testing. So you're describing the London style where you mock all the dependencies. So yeah, most of the time, I mean, there are 2 types of tests that I write for coverage. So in order to have full coverage, there are dependencies that you can mock, but at some point there are things you cannot mock, like database access.
Yeah,
so I adhere to the London style, and you can actually read posts online about London versus Chicago tests. So for unit tests, for everything that does not need to touch the database or the file system, or like some external service, everything that can just run as is, with just PHP, you can instantiate it. I mock all the dependencies. In cases where I need to test something like a repository, which does execute queries, like I don't care that it called this and that method in Doctrine or Eloquent. I mean, I'm not really testing anything. It's a fluid interface. It provides no value at all for me, and I still haven't tested the database part. So for those repositories, I write different kinds of tests where I do obtain the repository from the service container. So I would say, container get, and then I will execute those methods, and I will obviously reload the schema into the database. I will stage some data, and then I will assert, the output of the method or whatever impact it had on the database. Now, as for mocking, so you can mock and stub. So those are 2 separate things, really. It really depends on whether you think it has an impact. You can always write the tests, without too much mocking. If something happens, like it sends an email, obviously you don't have an output. You only need to make sure that you have sent an email to the email transport. So you can mock that to ensure that this method has been called with the correct email that has been assembled in the method. So that is good. And for so that's it. And for the rest, I try not to attempt to mock every single call, because then I become too bound to the implementation of the method. Because then if I want to change how my method is done internally, all of my tests are no good. So like I don't go overly zealous with that. Now, let me just check what's happening on Telegram. And then what I can do later on is use mutation testing. And then if I see that, basically it changes code, it like flips the Boolean conditions, things like that, comments out lines. And if your tests are not failing with those changes, then maybe you need to dial up the how much you inspect, basically, the calls. But if you don't need to, then that's fine. If all of your tests basically survive the mutations, then you're good to go. Your tests are as reliable as they can be.
Yeah, okay, thank you. Yes, for database tests, of course, we do the same. So we have the scheme and the gateways, and they take the data from the separate test scheme. Yeah, thank you.
You're welcome. yeah, I'm planning to make videos on those subjects as well, but I still have my queue of, things that people ask me on Patreon, and then I need to finish the solid principles, and then I'll get into some more testing stuff.
Yeah, of course.
Yeah, and now I just committed myself to a whole bunch of work because this is recorded and it's going to be public. So yeah.
Yeah, we won't tell anyone. Yeah.
Well, it's recorded, so. Roman, could you read the question that you got?
Yeah, so the question is, I mean, I don't know if this is really a question. I need to learn more how to implement the interface and to use it in applications. I'm still a junior.
Okay, so I have a very good answer for that.
Okay.
I have a video on YouTube. So just Google my name, Anna Filina, YouTube, and then the terms interfaces, and you're going to end up on a nice video with dogs in the thumbnail, and that's going to be the one you want to watch, and it's going to explain both value objects and interfaces. It's a very short video, quite approachable for juniors, so I hope it will help you.
Yeah, it's really easy to find. I was able to find it just right now, so
okay, cool.
Cool. I have another question from myself, if you don't mind. So you mentioned requirements. So could you give some tips on how to gather requirements good? And because there's always a problem that the business people, they forget something, and you just need to ask them more questions, and I don't know what to ask. And
I get your general, like, the pain points. I understand it. I don't think there's any actionable advice I can give you, because it just comes with experience mostly, like what are the right questions to ask. But always think that, once you write out the scenario, and let me see if I can actually share my screen, one of the slides that I showed you.
You should be able.
Yeah, I just need to find the slide first. Okay, so for example, here. So once you write what's called the happy path, let me share. Oh, the host, is the host around?
Yeah, Ksenia, could you please allow sharing screen? I will ping her in Telegram.
Okay. Well, let me describe it anyway.
Yeah,
so remember how I had this this test where I said, given I selected a membership option, when I enter valid credit card details, then I should see a payment receipt. Okay. So the questions you might ask based on that scenario that you need to have that scenario in order to start your sprint, right? To start the user story. So without that, it's like you haven't really agreed on anything. You don't know how you're going to go about testing it. Once you have that at the beginning of the sprint, you will have that scenario, that happy path at least. And then you look at that and you can ask questions. Well, given I selected a membership option, are there cases where, based on the membership option, the payment is going to look different? Like, am I not going to be able to use certain payment options? Like, for example, if how some stores will sometimes say, well, no credit cards, for payments under $5, you can only pay cash, right? So this is a valid scenario. So once you look at the given and you say, well, can that have an impact on the scenario, and you let the PO answer the question, then you go to the next step. The next step is, when I enter valid credit card details, well, can it be invalid? How can it be invalid? What kind of invalid states can you have? So if the credit card is expired, maybe because now you have this system with the banks, you can like auto renew the information directly from the bank. I know Apple Pay does that, Visa Checkout does that. So when you enter a credit card number into their system, into the e-wallet, they would actually, in the background, when a new credit card is issued, they're actually going to get information from the bank. So you cannot just say, hey, my stuff expired. My stuff is going to expire, so I don't need to cancel my subscription. No, it's still going to go through because they're going to get your new credit card information. So there's that. The other, so you can ask that question. So if it expires, maybe you can trigger that. If the credit card, if it still fails after that, then maybe you want to present a particular information to the user. You want to tell the user what to do, like please try a different payment method, and you will bring them to the screen again to ask them to enter that. If they enter the incorrect postal code, then maybe that's not the end of the world. Maybe you have a scenario where they can say, well, actually a postal code is not like a critical failure for us, because that just means that we were unable to verify the address. So it's just going to have a higher fraud score. But for that amount of purchase, that's not a problem. We can, worst case, we'll just, if it gets contested, it's cheaper for us to refund than to say no to the customer who might have just made a small mistake. Things like that. So you can have all these scenarios. So basically for every step, you ask questions like, well, what happens? Like, can this have an impact? Can this have an impact?
Okay, I got it.
That can help guide you. But yeah, no, for the rest, it's a lot of experience. You're gonna come up with questions that you can't even foresee until you actually start coding. And then based on the code, you might have interesting questions.
And what about non-functional requirements? At what point should I ask those? For example, performance. Should I ask this before even developing anything, or?
It depends on the company, depends on their processes. I know that when I worked for a big bank, it's like the biggest bank here in Quebec, they had a document basically where they listed how many requests they expect for this and that, how often is this process used, things like that. So how many records do we expect to get back from this and that? So they actually had that built in because they, by default deal with a lot of data. So those are questions you can ask, if it's something that's relevant, if it's something that will impact you, then you have to ask the question. And sometimes asking a question, how often will this happen? Like, for example, you want to account for an edge case, okay? You can spend 5 days coding that, but then the PO, and we had that actually once we were discussing this edge case, and then the PO said, yeah, but this is going to happen like 5 times per year. People can just manually fix it in their system. I'm like, oh, okay, so we're not going to include that. We will write, however, that we excluded this scenario. So we had like a testing strategy also that we described which scenarios we excluded and why. And we said, well, this scenario is possible, but we don't care because fixing it manually is cheaper than implementing that into the system. And people, at the bank, they have their little sheets with processes, right? And they just follow step 1, step 2, because they have to be conformant to all the, all the laws. So yeah, they just follow the steps. And it's good that we asked the question and we got a very unexpected answer.
And save you some time.
Yeah, it's very nice to be able to cash in those story points earlier.
Yeah.
Anyone else has a question? I'll stick around for maybe 5 minutes and then my voice is going to be dead because I gave a talk just before this.
Yeah, I understand.
Do you hear me?
Yeah, Ivan. Yeah, hi.
I want just to describe my question more clearly. So, for example, we have like PHP CLI script, which could lead. Sorry, something happened.
Yeah, the host muted all the participants.
Oh, okay. So for example, PHP CLI script, and it's processing, for example, 10 megabytes of data. So if we use a lot of classes, for example, it's CSV file, there is a lot of lines. If we describe every line as an object, we will fill our memory for seconds.
Yeah. Well, I mean, obviously there are some considerations for performance. The value objects, they really help you sort of model the problem very well. it doesn't mean that you have to completely go away from them. Some things might still be described this way, and that's fine. But if you do have performance issues, you can optimize that when you get to that problem. But that doesn't prevent you, I would say, from at least modeling all the things, and then only, like, I guess, unmodel the things where the problems are going to happen. Because let's say you are processing a customer, and that customer has 5,000 transactions that you need to process for them. Okay, well, does having the customer in memory for the time that you're processing all the transactions, is that a problem? Maybe not. The transactions might not be modeled, but at least the customer is, so that helps. Every little bit helps.
Okay. Thank you.
All right, I'll take the last question, and then I'm out of voice because, as I said, I've been speaking for 5 hours straight.
Wow.
Because I had to rehearse each of the talks also. I gave 2 talks.
Insane.
Yeah.
I think we can conclude on this because we don't have questions from participants anymore, and you answered all my questions. So thank you so much for your talk and for answering the questions. See you next time on PHP Russia, offline, hopefully.
I appreciate the opportunity. Thank you very much. Have a good day.
Thank you. Bye.